Yo, 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 yo! This is G coming at you live with the video on rational numbers and decimals. Let's get it! So, 3 key terms today. Make sure you get them all down. First is a rational number. It's any number that can be written as a ratio. And a ratio, aka, is also known as a fraction. So if I can ever write a number as a fraction, it is considered a rational numbers. And just so you know, every single, our decimals, not every single decimal, but almost every single decimal can be written as a fraction as well. So decimals are rational numbers. Fractions are rational numbers. Any number that can be written as a decimal. As a fraction or as a ratio. Whole numbers are rational numbers because if I have the number 3 and I put it over 1, that's now a fraction. Okay. If I add 1.25, that is the same thing as 1 1/4. That is a fraction. Okay, so any number that can be written as a ratio or a fraction is a rational number. Now, some of you might be asking, what would be an example of something that is not a rational number? And an example of something that's not a rational number would be pi. Because pi is a decimal that repeats and goes, that does not repeat and it goes on forever. So pi would not be rational. Also, imperfect square roots. So if you know what a square root is, the square root of 4 is a rational number because that's equal to 2, because 2 times 2 is 4. Square root of 5, we don't know what it is. Okay, therefore it's a decimal that goes on forever and it does not repeat. That is not a rational number. We call that irrational. Okay, but all you need to know is that rational numbers are numbers that can be written as fractions. Okay. We also have 2 types of decimals. We have terminating and repeating. Terminating decimals is one that stops. So like the example I had before, 1.25, that's a terminating decimal. A repeating decimal is one that repeats infinitely. So 1.3, and then we have that repeating sign over it, repeating, like so. Okay. Looking at our notes today, what we're going to do is we're going to convert rational numbers to decimals. We're also going to determine if it's a repeating or a terminating decimal. Okay, so we're converting fractions to decimals. Okay, so they're automatically already rational since they're all fractions. Okay, and we're going to convert them to decimals. Now, here's the cool thing about fractions is fractions are just division problems. That's all they are. So this is 6 4/9. If I wanted to change this into a decimal, I know because it's a mixed number here, I don't need to make it improper because that's doing way more work than we need to. I know that my decimal has to be 6 point something because that's what this is. This is 6. This is 6 as the first number or the whole number. If I didn't have this, it'd be 6. But now I have this extra stuff over here on the side. Okay, this extra stuff, that's the point something. So really what I'm doing is I'm just converting the 4/9 to a decimal. And 4/9 is just a division problem. And this goes back to our dividing integers video from module 2. 4/9 is a division problem, and we set it up as the top dog always goes inside the house, the bottom guy goes outside. So this is just 4 divided by 9. Now that I have 4 divided by 9 set up, I actually have to do my division. But we'll notice that right away, well, 9 does not go into 4 evenly. That's okay, so we're going to put a 0 there. Now is where I get to add a decimal and make it 4.0. 4.0 is fine. That is, I haven't changed, I haven't added anything to 4. I can write 4.0000 if I want to, and it's still the same thing. 4.0000 is still just 4. So we're not changing it. We're just adding some zeros so that now it makes it better for us, easier for us to divide. Because now I can look, does 4 go into 90? Because once I add that decimal, I bring it straight up. And it's important to stay in line here and organize because the decimal placement matters. So that's why I made sure I put the 0 above the 4 because 9 goes into 4 0 times. So now I'm looking at, does 9 go into 40? And 9 goes into 40 4 times because 9 times 4 is 36. I subtract that and I'm left with 4. Bring down my next 0. 9 goes into 40. Oh, it goes into 4 times. If we notice right away, we already have a pattern. Okay, because I'm just going to keep doing 40 and 36 over and over again. It's just going to keep happening. So that's when we have a repeating decimal. And our repeating decimal is just a 4. You don't have to put both 4s. You can just do one 4 because this single 4 is repeating right here. So the answer is 6.4, and the 4 is repeating. So I want to state if it's terminating or repeating, it is a repeating decimal because the 4 is repeating. Okay, now looking here, we have 3 more examples. We'll do this first one together, and then I'll let you guys try the next 2 on your own. So this first one, this is 10 divided by 4 is what this is. Okay, so I'm just going to set it up just as that. 10 divided by 4. Well, 4 goes into 10 twice. Subtract 8, I'm left with 2. Do I get to stop there? No, I do not. The reason why I don't is because I still have more remaining here. I don't get to say 2 remainder 2. We don't do that anymore. So I have to add my decimal and a 0, bring my decimal straight up. Okay, so now when I add that 0, I'm actually going to bring it down. So now like 4 goes into 20 5 times. Subtract 20 and I am done. So my final answer was 2.5. Another way I could have solved that one in particular, especially when it's over 4 and I have even numbers like that, whenever we have over 4 over 2, it might be even better to change this to a mixed number. So I could have changed it to a mixed number by doing, again, 10 divided by 4. 4 goes into 10 twice, just like what we did, subtract 8, I'm left with 2. But now this becomes my new numerator, and I keep my old denominator. So it's 2 and 2/4. Well, a lot of us know that 2/4 is really just 1/2, and we know that 2.5 is just 2.5. So you could have done it that way as well. Either way, you would have gotten to 2.5. All right, and 2.5 is a terminating. I'm going to put term. It is a terminating decimal because it does come to an end. Okay, so if you haven't done so already, please pause and try these last 2 on your own, and then you can check back and see how you did. Okay, so now I have a quick joke for you. Why should you never argue with a decimal? Why should you never argue with a decimal? Because a decimal always has a point. That's one of my favorites. That's a good one. Solid. All right, moving forward. 7 over 11. Again, it's a fraction. It's division. Top dog always goes inside the house. So this is 7 divided by 11. 11 goes into 7 0 times. So I'm going to add my decimal, my 0. And then here we go. It goes in 6 times. Subtract 66. I'm left with 4. I'm going to bring down another 0. Let's see. 11 goes into 43 times. Bring down 33. And I'm left with 7. Isn't this what we started with? Didn't we start with 7 and 11? Because now if I add another 0 and I bring that down, I feel like I'm going to be, this is exactly where we were just at. Not that I feel like it. It's that this is what's happening. We have the exact same thing. I'm going to go 66 again, then I'm going to subtract. I'm going to have 40. So I have a repeating decimal. So it's 63 repeating. So 0.63. Both the 6 and the 3 are going to repeat because I'm going to have 6 now again, then I'll have 3 repeating. So the line has to go over both the 6 and the 3. And then we would write down it is a repeating decimal. Finally, the last one, we have 7 and 3/15. Now, for 7 and 3/15, I know it has to be 7 point the extra, so really I'm just converting the 3/15. So that's 3 divided by 15. And I need to start by adding my decimal and a 0 right away. 15 goes into 30 twice. I'm already done. That was a nice and simple one. So it should just be 7.2. And that is a terminating decimal. Okay. So under things to remember, I would write the number one mistake I see, you guys, is when we were doing like 3 divided by 15, is people tell me the answer is 5. That's the number one mistake I see. Because they are doing 15 divided by 3, not 3 divided by 15. They're getting it backwards. So what I would do under things to remember is I would talk about what order to write your division in. Okay, so I would talk about what order to write your division in. So you could put 3 divided by 15 is really 3 divided by 15, which is really 3 divided by 15. Maybe draw that sequence to show you how you're supposed to set these up each and every single time. You could also show, again, that the top dog gets inside the house, and if you're in the basement, you go to the outside. Okay? Anything like that to show you that that's the correct order, because I guarantee you if I had this on a quiz, what I'm going to see, or if I saw someone working on this problem, if I saw 20 people work on this problem in class, that people will give me the answer of 5 because they're just going to do it real quick and they're not going to divide properly. So just be aware of that. And that's all I got for you guys. I hope this helped. Let me know if you guys have any questions. Gradius.